So welcome to this video series on aptitude presented by Mentors4ias in association with Bangalore IAS Academy and NammaKPSC. So in this particular session, we will be starting off with another new topic, that is boats and streams. Now boats and streams, once again a very important topic, and when it comes to your competitive exams, it is very much possible that you might have questions on both side streams. See, with many varieties of questions which can be solved with respect to concepts of time, speed, and distance, boats and streams is also one among them. Meaning, if you understand the concept of time, speed, and distance, you should also be able to solve problems of boats and streams. Of course, there are few other things that you must know, but at the same time, it will rely on the concept of time, speed, and distance. Meaning, if this is done, you should be able to solve, you should be able to understand, you should also be able to comprehend problems when it comes to boats and streams. Now, when it comes to boats and streams, basically you'll have four types of questions under boats and streams. Basically, you'll have four different types of questions under boats and streams. One is where you will be given the speed of the boat in still water and the speed of stream, and you will have to find the time taken by the boat to go upstream and downstream. Second type is where you will be given the speed of the boat to go up and downstream, and you have to find the speed of the boat in still water and also speed of the stream. The third type of problems when it comes to boats and streams is when you will be given the speed of the boat in upstream and downstream, and you will be asked to find the average speed of the boat. That is the third type. And finally, the fourth type of problem is when you will be given the time by the boat to reach a place upstream and or downstream, and you will be asked to find the distance to the place. So these are the four different types of questions that will be asked. However, if you've not understood what are the four different types of questions, it does not matter. As long as you are able to follow when we solve the problems, that is more than enough, because we will try to take up different types of problems as we move on ahead with the session on boats and streams. However, with respect to introduction when it comes to boats and streams, as the name itself suggests, you should understand that you will have a boat, you'll have a boat where the boat is able to navigate a stream. See, the topic itself is boats and streams. Boats and streams. Now, if you have a boat, obviously you have a person in it where the person is able to row the boat in moving water. So when we say that it is a concept of boats and streams, meaning there is a boat which is able to move in still water. Obviously, this boat will have some speed, or the person is able to row the boat at some speed in still water. However, when it comes to a stream, stream is not still water, stream is moving water. You have water which is flowing, meaning water itself will have its own speed. Then the speed of the stream will affect the rate at which this boat is able to move, depending on whether the boat is moving along with the stream or in the opposite direction. So for example, take this image over here. Okay, so in this particular image, imagine the water to be flowing in this direction. Okay, so the stream is flowing in this direction, that is towards your right. So what I'm going to say is that let us assume the speed of the boat in still water to be b kilometers. Okay, so always we will take speed of the boat in still water, speed of the boat in still water to be b kilometers per hour. So whenever solving problems, if I write B, B means what? B is the boat, B is the speed of the boat in still water, meaning it is the rate at which the man is able to row the boat in still water, say for example in a pond or a lake. But this is not the speed in the stream, it is only the speed of the boat in still water. So I am representing it as B kilometers per hour. Similarly, as I've said that the stream is moving in this particular direction, stream, river, creek, whatever it is, the stream itself will have its own speed. So let the speed of the stream be represented as S. So whenever I write S, S means it is the speed of the stream. So if I say S kilometers per hour, I am referring to the speed of the stream. Now there's a thing over here when it comes to boats and streams. Say if this stream is running in this particular direction, and if the person on the boat is also rowing or is also moving in this particular direction, then don't you think his speed will increase? His speed is nothing but the speed of the stream plus the boat. Similarly, if this person is now rowing the boat in the opposite direction, obviously the stream which is now flowing in this direction will offer resistance to the person who is now rowing the boat in the opposite direction. Therefore, his ability to row the boat in the opposite direction, the rate at which he is able to row the boat or the speed of the boat will come down. If you've understood this, I wish to now tell you about downstream and upstream. Downstream and upstream. Okay, so downstream means the man is rowing the boat in the same direction as that of the stream. So if the stream is flowing in this direction, then the man is also rowing the boat in the same direction. That is when we say it is downstream. Okay, so if the man is rowing the boat in downstream, then the actual speed at which the boat will be moving will be B plus S kilometers per hour, and we will call this as the downstream speed. Okay, so I am referring it to as capital D. See, if I write small d, it becomes distance. I am writing it as capital D. Capital D is what? It is the downstream speed. What is the downstream speed? It is the rate at which the boat is moving when boat is moving the same direction as the stream itself. How do we get that? We add the individual speeds of the boat as well as the running water, that is the speed of the stream. Similarly, we have upstream. Upstream is when the man is rowing the boat in the opposite direction of the stream. Meaning, if the stream is running in this direction, the man is running the boat in this particular direction, that is the opposite direction. Therefore, the stream will offer resistance, and hence the speed of the boat, the rate at which the boat is able to move, is brought down. It is no longer B kilometers per hour, rather it is B minus S kilometers per hour. We will call this as the upstream speed. We will call this as the upstream speed. So downstream speed is the speed of the boat plus speed of the stream. Similarly, upstream speed is when the person is moving or the boat is moving the opposite direction of the stream. It is nothing but the difference between the speed of the boat and the speed of the stream. Okay, so always when it comes to boats and streams, the speed of the boat will be greater than speed of the stream. Speed of the boat will be greater than speed of the stream. That is why he is actually able to move in the opposite direction. If the stream speed is greater than the speed of the boat, the person or the boat will not be able to row in the opposite direction or move in the opposite direction. Therefore, the speed of the boat is always greater than speed of the stream. So if you have seen this, see, the speed of downstream is equal to nothing but boat plus stream speed. Upstream is nothing but boat minus speed of the boat minus speed of the stream. So now what if I add these two? What if I add these two equations, 1 and 2? What do you get? You get D plus U is equal to B plus B is 2B, S and S gets cancelled, you have 2b is equal to d plus u. Or I can say speed of the boat is nothing but half of downstream speed plus upstream speed. I don't want you to remember this. I don't want you to remember b is equal to half d plus u, but I'm just mentioning this since this is the beginning of our session on boats and streams. So it is important that you also know this, because any book or any source that you take, it will always try to give you shortcuts. But here again, I don't want you to remember any kind of shortcut. I don't want you to remember b is equal to half d plus u, because as long as you know that d is nothing but b plus s, u is equal to b minus s, which is obvious through common sense, you should be able to arrive at this. Similarly, what if I now subtract? What if I now subtract? So equation 1 minus equation 2. Then what do I get? I have d is equal to b plus s over here, u is equal to b minus s over here. I subtracted d minus u, b and b gets cancelled, is equal to 2s. Therefore, similarly, the speed of the stream is nothing but half of the difference between the downstream speed and the upstream speed. So similarly, you can actually have several shortcut formulas as well. Say for example, okay, now if you take up any particular source or whatever it is, say for example, I've mentioned that one type of question is where the question can ask for the average speed. Okay, the question can ask for average speed. Now many different sources will represent the shortcut for average speed as nothing but b plus s, b minus s divided by b. Now here you have to remember this average speed. You have to remember the average speed. But I'm asking you not to remember the average speed, because you please, as I've mentioned earlier, please use the memory for your general studies, not for aptitude, because as long as you understand the concept, you should be able to solve it. See, here I will show you how do you get this average speed as b plus s into b minus s divided by b. See, going back to time, speed and distance, average speed is what? Average speed is nothing but 2xy divided by x plus y. Here the speed of downstream is what? B plus s. U is what? B minus s. So if you take d and u, what should be the average speed for d and u? It is nothing but d into u divided by d plus u, correct? This is your average speed. Instead of x and y, I'm writing it as d and u. Now substituting d and u as b plus s and b minus s. Now what do you get? Instead of d, I am going to write b plus s, and instead of u, I am going to write b minus s divided by d plus u. This is nothing but b plus s plus b minus s. S and s gets cancelled. I have 2b. What am I left with? I am left with 2 into b plus s, b minus s divided by 2b. 2 and 2 gets cancelled. This is nothing but b plus s into b minus s divided by b. Now why do you have to remember b plus s into b minus s divided by b, which is referred to as the shortcut in boats and streams, when you already know average speed is 2xy divided by x plus y? And obviously here also you know that it is no longer required, you need not even remember the average speed as 2xy divided by x plus y, because you also know that average speed is nothing but total distance by total time. So we've already done this, total distance by total time, meaning what? If a person is going from A to B and is traveling a distance d, onward journey is x kilometers per hour and return journey is y kilometers per hour, then average speed is what? Nothing but total distance by total time. So if he's going and coming back, what is the total distance? Total distance is 2d divided by total time. What is total time? Onward journey, what is the total time? Nothing but d divided by x. Return journey, what is the time? D divided by y. I am doing t1 plus t2 time to get total time. So this is nothing but 2d. I take d common out. I have y. I have x divided by xy. I take this to the numerator. I have 2d divided by d into xy divided by x plus y. D and D gets cancelled. What am I left with? I'm left with 2xy divided by x plus y. This is nothing but your average speed. Meaning what? You need not remember anything. You need not remember anything. As long as you understand the concept, you should be able to arrive at the shortcut itself rather than trying to remember the shortcut. It might take you a minute extra, but it is fine. You should be able to solve the problem, which is more important. So without wasting more time, let us actually move on to the concept itself. Let us solve a few simple problems when it comes to boats and streams. Okay, so the first question. Now, the first question says, in 1 hour, a boat goes 11 kilometers along the stream and 5 kilometers against the stream. Therefore, what is the speed of the boat in still water? So, what the question is saying is that there is a stream, okay, there's running water, say in this direction, and there is a boat. There is a boat, obviously, maybe a person on the boat who is rowing it, or maybe a motor boat, whatever it is. Okay, so the question says, in 1 hour, a boat goes 11 kilometers along the stream. Along the stream meaning downstream. Okay, so downstream, the person is able to go 11 kilometers in 1 hour. What does this say? Downstream speed is nothing but 11 kilometers per hour. In 1 hour, he is able to travel 11 kilometers, meaning downstream speed is 11 kilometers per hour. The question also says the boat is able to travel 5 kilometers against the stream in 1 hour, meaning upstream speed. Meaning upstream speed is what? That is also 5 kilometers per hour. Now it is in 1 hour a boat goes 11 kilometers downstream and 5 kilometers against stream. Here it does not mean in 1 kilometer he is going and coming back. It is rather individually. Sometimes the question may be confusing. Then if you do not get any answer which is going to match with your options, you might have to change it, because here according to the statement it could also mean that in 1 hour itself is traveling 11 kilometers and 5 kilometers back. So sometimes you might have to solve the question to see if you're getting the correct answer or not. If not, you'll have to change the understanding. You'll have to change your understanding of the question itself. However, coming to this particular question, I hope you've understood what is D is equal to 11 kilometers per hour, U is equal to 5 kilometers per hour. Therefore, what is speed of the boat? What is speed of the boat? For us to get speed of the boat, what is downstream? Downstream is nothing but B plus S, where B is the boat of the speed of the boat, S is speed of the stream. What is U? U is nothing but upstream speed, B minus S. Question is asking for speed of the boat. So I'm going to add these two equations. Let me just add these two equations. 11 plus 5 is what? 16. 16 is equal to B plus B is 2B. S and S gets cancelled. Therefore, B is what? B is nothing but 16 divided by 2 is 8 kilometers per hour. Or else, as I had mentioned earlier, you could have straight away written B is equal to half of D plus U, which is nothing but half of 11 plus 5. 11 plus 5 is nothing but 16. One thing, 16 divided by 2 is nothing but 8 kilometers per hour. This is nothing but the same thing. Okay, so you don't have to remember B is equal to half D plus U. Just always remember downstream is B plus S, summation of the speeds. Upstream is the difference between the speeds. So here the correct answer is 8 kilometers per hour, or option C. So it is 8 kilometers per hour. Second question. The second question says a man can row upstream at 8 kilometers per hour. So U is 8 kilometers per hour and downstream at 13 kilometers per hour. Upstream at 8 kilometers per hour, downstream at 13 kilometers per hour. Whenever you have a big question with 3 or 4 statements, here it does not matter, just 2 statements. Always make the habit of underlying these values. Always make the habit of underlying the values. It will make it easier for you to capture the information in your head. Now coming back to the question, so the question is saying what is speed of the stream? What is speed of the stream? Meaning what is the speed at which the water is actually moving? Now obviously S is nothing but half into D minus U. half into D minus U. But obviously I don't want you to remember this. So D is 13 kilometers per hour, which is what? B plus S. U is 8 kilometers per hour, which is what? B minus S. Okay. So now I am going to subtract it. I am going to subtract. So D minus U. D minus U. So 13 minus 8, B minus B, S minus of minus S, which becomes plus. 13 minus 8 is 5 kilometers per hour is equal to 2S. Therefore, S is equal to nothing but 5 by 2 or 2.5 kilometers per hour. Therefore, speed of the stream is what? It is 2.5 kilometers per hour. It is option A, 2.5 kilometers per hour is the correct answer. Next question, it is question number 3. Now, question number 3 says, a man rows downstream 32 kilometers and upstream 14 kilometers. A man rows downstream 32 kilometers and upstream 14 kilometers. If he takes 6 hours to cover each distance, meaning he takes 6 hours to row downstream covering a distance of 32 kilometers, he again takes 6 hours to row upstream for a distance of 14 kilometers. So now the question is asking for the speed of the stream. What is speed of the stream? Now, in order for us to find out the speed of the stream, we need the downstream speed and we need the upstream speed. What is speed? Speed is nothing but distance by time. This speed is nothing but distance by time. See, even in a river, he is always, a person may be going from point A to point B. He may be returning from point B to point A or from B to C midway, whatever it is. But obviously, just like traveling by road or traveling by rail, even by water, you're going from one place to another place. Okay. So downstream speed is equal to distance. Downstream, what is the distance traveled? It is 32 kilometers. In what time? In 6 hours. Similarly, upstream speed is nothing but the distance traveled, which is 14 kilometers, in what? 6 hours. Therefore, we now have the downstream speed. We also have the upstream speed. So, downstream, which is equal to 32 by 6, is nothing but B plus S. U is what? 14 by 6, which is equal to what? Nothing but B minus S. So we now subtract. Everything. This becomes plus. What do we get? We get 32 by 6 minus 14 by 6 is equal to B and B gets cancelled. It is nothing but 2S. Therefore, 2S is equal to what? See, since the denominator is common, it is 32 minus 14. 32 minus 14, 2, 1, 18 divided by 6. 6, 3 is 18. Therefore, S is equal to nothing but 3 by 2 is equal to 1.5 kilometers per hour. Therefore, speed of the stream is 1.5 kilometers per hour, or it is option C, which is the correct answer. It is 1.5 kilometers per hour. Next is question number 4. Now, question number 4 says, a boat running downstream covers a distance of 16 kilometers in 2 hours. A boat running downstream covers a distance of 16 kilometers in 2 hours, while for covering the same distance upstream it takes 4 hours. What is speed of the boat in still water? Now, this question is very similar to the previous question. So what do we take? We start off with the downstream speed, which is capital D. Downstream speed is equal to the distance traveled and the time taken to travel that distance. What is the distance traveled downstream? It is 16 kilometers. The time taken to travel 16 kilometers downstream is nothing but 2 hours. Therefore, 16 by 2 is equal to B plus S. Similarly, upstream. So question says, while covering for the same distance upstream, it takes 4 hours. So to travel the same distance upstream, it takes 4 hours. It takes 2 hours extra. So b plus s is nothing but 16 by 2, or b plus s is equal to nothing but 8. 16 by 2 is nothing but 8. Similarly, b minus s is 16 by 4. 16 by 4 is nothing but 4. Now the question is asking for what? What is the speed of the boat in still water? Therefore, we will add these two. B plus b, we get 2b, s and s gets cancelled, is equal to 8 plus 4 is 12. Therefore, b is 12 by 2, it is 6 kilometers per hour. Therefore, the correct answer is 6 kilometers per hour. It is option B. It is option B. Next question. Now the question says, question number 5 says, a boatman goes 5 kilometers against the current of the stream in, a boatman goes 2 kilometers against the current of the stream in 1 hour and goes 1 kilometer along the current in 10 minutes. Therefore, how long will it take to go 5 kilometers in stationary water? How long will it take to go 5 kilometers in stationary water? Okay, so now starting off with the question. A boatman goes 2 kilometers against the current of the stream in 1 hour. Meaning what? We have upstream speed. Upstream speed is nothing but distance. Distance traveled is 2 kilometers. The time taken is 1 hour. Meaning what? 2 kilometers per hour is equal to B minus S. Similarly, the person goes 1 kilometer along the current, that is downstream speed, in 10 minutes, or I can say in 1 hour. He travels a distance of 1 kilometer in 10 minutes. What is 10 minutes? 10 minutes is nothing but 10 by 60. So 60 goes up. We get what? We get 60 by 10. 60 by 10 is nothing but 6. Therefore, B minus S, here B minus S is equal to 2 kilometers per hour. B plus S, downstream is B plus S, is nothing but 6 kilometers per hour. Now the question is asking how long will it take to go 5 kilometers in stationary water. So the question is asking is, what is the time taken by the boat to travel 5 kilometers in stationary? Then in order to determine the time taken to travel 5 kilometers in still water, we have to determine the speed of the boat. How do we determine the speed of the boat? We will add these two equations. So 2b, s and s gets cancelled, is equal to 8, or b is equal to 4 kilometers per hour. So the distance to be traveled is what? 5 kilometers. Okay, so the speed of the boat is what? 4 kilometers per hour, meaning in 1 hour it would have traveled 4 kilometers. What is the remaining distance to be traveled out of 5 kilometers? It is nothing but 1 kilometer. So what does this mean? If the boat is able to travel 4 kilometers in 1 hour, then in half an hour it will travel 2 kilometers. In 15 minutes it will travel 1 kilometer. So apart from 1 hour to cover 4 kilometers, it will take plus 15 minutes to travel that another 1 extra kilometer. Therefore, the total time taken to cover 5 kilometers in still water, stationary water, will be 1 hour 15 minutes. It will be 1 hour 15 minutes. Therefore, the correct answer is 1 hour 15 minutes. The correct option is option C. This option C. Next question. Question 6 says, a man takes twice as long to row a distance against the stream as to row the same distance along the stream. What is the ratio of the speed of the boat to the speed of the stream? So, a man takes twice as long to row a distance against the stream to row the same distance along the stream. So again, downstream speed will be d and upstream speed will be u. Let us take t to be the time to cover distance d, to cover distance d downstream. Now the question says the man takes twice as long to row a distance against the stream as to row the same distance along the stream. Meaning what? If t is the time taken to travel the distance d downstream, then to travel the same distance upstream, the man will take double the time. The man will take double the time. So we have t is equal to d divided by capital D, that is your downstream. Also 2t is equal to nothing but small d, that is distance, divided by u. Or I can write this as t is equal to, I am going to take 2 over here, d divided by 2u. Meaning what? See here, time t is equal to distance divided by downstream. Similarly, time t is equal to distance divided by 2 times the upstream speed. Therefore, t is equal to d divided by 2 times upstream speed is equal to d divided by the downstream speed. D divided by the downstream speed. D and D gets cancelled. What do we get? I take d over here, downstream speed over here, upstream speed over here. D, capital D is equal to 2u. What is capital D? Nothing but b plus s. What is capital U? Nothing but b minus s. So what do we have? We have b plus s is equal to 2b minus 2s. I take s to the left hand side, I take b to the right hand side. So I get s plus 2s is equal to 2b minus b, or 3s is equal to b. I take s to the other side, I get 3 is equal to b by s. So what are we left with? We are left with b by s is equal to 3, or b by s is equal to 3 by 1, meaning what? The ratio of the speed of the boat is to stream is nothing but 3 is to 1. Therefore, the correct answer is 3 is to 1. It is option B. It is option B. Therefore, the correct answer is 3 is to 1, option B. So here we have few practice questions. There are 3 practice questions. So if you've understood, I've taken very simple questions since it is the beginning, since we are just starting off with boats and streams. They're very simple questions. If you've understood, you should be able to solve these questions as well. Still, if you do have any doubts, please do write to us in the comment sections. I will send the solution, I will send the answers as and when possible to the NammaKPSC handle. If it is not very late, if you ask me maybe after many days, I might miss out on it. But anyway, if you ask in the within a few days after the video is released, I might be able to send the solution to the NammaKPSC handle. However, due to their time constraint, they will not be able to upload the answer as soon as possible. But still, do check, please do try it. If you understand, you must have confidence in yourself, you will be able to solve it. The answer that you get should be correct. So thank you for watching. Please do follow us for more such videos.